This module includes a desktop mechanisms trainer for students to investigate mechanical components and systems that would otherwise require access to a workshop. They build and test a range of different systems that incorporate gear wheels, belt drives and pulleys. By using on-screen simulations of the mechanical systems included on the hardware unit, you can turn every PC into a mechanisms trainer. This means that you only need one hardware system in the classroom for group demonstrations and team problem-solving tasks. If you look closely, you'll be amazed at how many times the basic mechanical components provided on the trainer are used all around us in tools, equipment, machines and gadgets. All engineers and technologists need an appreciation of mechanical principles, whatever their specialist field. This module teaches the fundamental principles and brings the subject to life by engaging the learner in hands-on tasks. The well-written ready-made lessons supplied with this module help tutors introduce topics and allow students to go on and carry out investigations independently and within teams. The learning content is designed for flexible delivery from a PC, server system or internet connection. Its HTML format meets the requirements of the SCORM standard for access on a virtual learning platform. It includes continuous and summative assessment for automatically tracking and marking students' progress. The curriculum material also includes opportunities for students to demonstrate their ingenuity and problem-solving skills during set design challenges. Theory presentations in PowerPoint are used by tutors to introduce topics and cover key concepts. When used with a student response system, automatic tracking of the integrated questions and instant feedback helps engage and excite the students. This also saves valuable tutor time with automatic marking and reporting. Students draw on the knowledge and skills gained as they work through the curriculum. Some of the skills they gain include assembling gear trains and calculating gear ratios, identifying different types of motion in mechanical systems, comparing toothed and pulley belt drives, experimenting with levers and pulleys to observe force and distance relationships of effort and load, setting up and monitoring cam profiles, and calculating the mechanical advantage provided by an inclined plane. The Mechanisms Trainer enables tutors to devise design challenges for students to put theory into practice. For example, configuring a motorised winch, setting up and operating an elevator, and interconnecting a drive mechanism for a car engine valve. Within the activities, students apply various scientific laws and principles. They also perform mathematical calculations in the context of real engineering systems. This approach makes the ST260 a great application for a STEM programme.